Hi everyone, today we are going to start the last section of Chapter 4, which is use isosceles and equilateral triangles. So what is an isosceles triangle? An isosceles triangle is a triangle with two congruent sides. So if we look here, we have a diagram of an isosceles triangle. The two sides that are congruent are called the legs. So those two sides right there are the same length, called the leg. The third side that is not congruent is called the base. Now this top point that connects the two legs together is called the vertex, and the angle that is created from the two legs is called the vertex angle. Now looking back at the base, the two angles that are created by the legs and the base are called base angles, and these angles are actually congruent. They are the same measure. All right, so now here's an isosceles triangle. I see that because of these tick marks, so I know that this side is the same length as this side. Name the vertex angle. Well, I know that the vertex is I because it connects the two legs together, which means the vertex angle would then be angle I. Name the base angles. Well, first I need to figure out where's the base. The base is the third side that is not congruent. And the angles created from the base and the leg are this angle and this angle. So the two base angles then are angle R and angle T. Finally, name the base. Well, I highlighted the base, and the base is segment TR. Or you could have also called it RT. Isosceles triangle base angle theorem. If two sides of a triangle are congruent, the angles opposite of those sides are congruent. So if I look at this here, it just tells me that if I have an isosceles triangle where my legs are congruent, the base angles are also congruent. So if I look at my example here, if I know that AB is congruent to BC, that means that angle B is congruent to angle C. The base angles are congruent. All right, so here's our next example. If HG is congruent to HK, so let's mark that out. HG is congruent to HK, then which two angles are congruent? Well, we need to figure out what are the base angles. And my base angles would be angle G and angle K. So I'm going to mark that angle G and angle K. Number 2, if angle KHJ is congruent to angle KJH, then which two sides are congruent? All right, so let's mark this in our diagram. HJK is this angle right here, and KJH is, oh, I messed that up. This angle is HKHJ, and this angle is KJH. If those two are congruent, which sides would have to be congruent? Well, those are the base angles, which means this is the base. So the other two sides would be the legs, which means they are congruent. So that would be side HK and segment KJ. All right, so I have an isosceles triangle here. I see that because of these two tick marks, meaning that those two side lengths are the same. So let's find the measure of angle A. Well, if I look down here, I see we know this measure. This is 70. Well, if this is my base, which angle is congruent to angle C? It would be angle A. So that means that this angle is also equal to 70 degrees. So I'm going to write this. The measure of angle A is equal to 70 degrees. Now we need to figure out what is the measure of angle B. And let's remember that the angles inside of a triangle add up to 180 degrees. So that means B, and I'll call that X. If I have X plus 70 plus 70, this has to equal 180. And if you do some algebra, you end up getting that 40 is equal to X. So the measure of angle B has to be 40 degrees. All right, now we're getting into some tougher problems. PQ. PQ. This segment right here. I want to figure out the length. Well, if I look at my triangle, I do not see any tick marks, so I don't know right away which side lengths are congruent. But what I do see in my diagram are these two angles, angle A, angle A. They are congruent. So that means I need to figure out where my legs are at. Remember, the legs are opposite of our base angles. So that means that this segment is congruent to this segment. Now that I know this, I can solve for X and find PQ. So here we go. 17 is equal to 4X minus 9. Add 9 to each side. And I get 26 is equal to 4X. Divide by 4. Divide by 4. And I get that 6.5 is equal to X. But I'm not done yet because I didn't want to find X for the first problem. I guess I could put X here, 6.5, because that is the second problem. I want to figure out what PQ is. So I need to plug X back into the equation for PQ, which is 4X minus 9. So that would become 4 times 6.5 minus 9. And when I plug that in my calculator, I get 17. So this then is 17. And finally, PR. PR is my base angle, or my base. So I need to figure out what is this. Okay, and so I'm going to solve for X again. I'm sorry, not solve for X, plug X into this equation. And I have 2 times 6.5 plus 3. This is equal to 16. And I'm done. So PR is equal to 16. Next, we're going to talk about an equilateral triangle. Equilateral triangles are when all 3 sides are congruent and all 3 angles are congruent. So I see that by my tick marks that these sides are the same length and all these measures are the same, which means each measure has to be 60 degrees. So if a triangle is equilateral, then it is equiangular, and the opposite. If a triangle is equiangular, then it is equilateral. All right, so I have a triangle here. I want to find ST in the triangle at the right. Well, if I look at my diagram, I notice that all of my angles are congruent. Since this is an equiangular triangle, I also know that this is equilateral from the last slide. So all these side lengths are congruent. So since this side length, UT, is equal to 5, that means that ST is also equal to 5. Is it possible for an equilateral triangle to have an angle measure other than 60 degrees? The answer is no. Why? Well, we know that a triangle has to add up to 180 degrees. And there are 3 angles, which means each angle has to equal 60 degrees. If it doesn't, there's something went wrong. And finally, we have a proof here. So we are given that WB is congruent to WO. We are also given that TO is congruent to TI. We want to prove that angle B is congruent to angle I. All right, so here's my proof. What's the first thing I need to write? Well, it's my given. So I am given that WB is congruent to WO. I'm going to mark that here. So WB is congruent to WO. And I'm also given that TO is congruent to TI. So TO is congruent to TI. Why? Well, that was given. All right, so now looking at those two triangles, I see that I have two isosceles triangles. So since these are isosceles triangles, that means that this angle is congruent to this angle. I'm going to write this out. So I know that angle BO is congruent to, angle B is congruent to angle O. And the reason, that's the definition of isosceles triangle. All right. Well, if I look at angle O, I also know that these two angles are congruent. Why? Well, they are vertical angles. So I'm going to write this out. So part 3, I know that angle BOW is congruent to angle IOT. My reason, they are vertical angles. And lastly, I have an isosceles triangle for triangle TOI. So if O and I are base angles, we know that they are congruent. So I'm going to write this out, that angle I is congruent to angle O. And the reason there, definition of isosceles triangle. And so now I have proven that angle B is congruent to angle I by either the transitive property, or we could say substitution. I'll use substitution. And now we have proven that angle B, which I'll circle, is congruent to angle I.